Imagine building a production-ready AI application that combines Amazon Bedrock's power with GitHub Copilot without writing a single line of code by hand. Sounds crazy, right? Over the past few days, I worked with Copilot as my coding partner to create a real-world market analyst AI application. This application can analyze thousands of product reviews, calculate NPS scores, and even run retrieval augmented generation using Amazon Bedrock's knowledge base. Here is the catch though. While Copilot did 90% of the heavy lifting, from setting up Terraform IaC for AWS services to building a fast API backend to generating synthetic data, it was not all smooth sailing. At one point, Copilot even gave me completely wrong configurations that broke the entire application. But instead of abandoning it, I guided Copilot back on track with better prompts, and the results were honestly impressive. In this video, I will walk you step by step through how we built the system, the wins, the struggles, and the moments where Copilot completely surprised me. By the end, you will see not only how powerful Amazon Bedrock can be, but also how AI assistants like Copilot are changing the way we build software. And stick around until the end because I will show you the final demo of the Market Analyst AI application running end to end. Trust me, you don't want to miss that part. Let's kick things off inside VS Code. I'm starting Copilot in agent mode, and for this project, I have selected Cloud Sonnet 4 as the model. Now, instead of writing everything from scratch, I will give Copilot a single prompt, asking it to create the full project structure and the initial draft files. Watch this, the output is flying by 10x speed. In less than a minute, Copilot has set up my folders, created the starter Terraform code, and even drafted a README file. This README is worth a closer look. It not only explains the project but also organizes all the steps I will need to build this AI-powered app, something that would have taken hours manually. Copilot just handled it in seconds. Now I'm going to enter the Copilot prompt to update the Terraform code to make sure that it is using the right AWS provider versions and also the instructions to provision the S3 packets and the Lambda functions. As you can see, Copilot started updating the respective files in the repository. Since Copilot is in the agent mode, it also executes the respective Terraform commands as it makes the changes into those Terraform files so that it can test those changes on the fly. And of course, as anyone who has touched AWS IAM knows that we always hit the IAM permission issues right away. I also experienced these IAM related issues, but Copilot helped me to debug them and tweak the IAM policies. And finally, I was able to provision these resources successfully. Now, let us navigate through the AWS console to make sure if these resources were created correctly or not. Here is the S3 bucket named Market Analyst AI, and if we go inside that bucket, we can see there is a folder called data, and inside that data folder, there are two files, .json and CSV. Now let us also quickly navigate to the Lambda function and make sure if that Python Lambda function was created correctly. Yeah, there you go. As you can see here, the Python function also was successfully created. Infrastructure as code is not just about creating the resources, it's about repeatability. So I tried to destroy all these resources through the Terraform destroy command. And as usual, I got into the IAM permission issues. Yeah, there you see the IAM policies was not having the right permissions to delete the resources. So I updated the IAM policies and I re-attempted the Terraform destroy command, and I was able to delete all those resources through the Terraform destroy. Now let us also make sure through the AWS console. Yeah, there you go. You don't see that Market Analyst AI S3 packet. And also if we navigate to the Lambda function, we don't see any function. So we were able to successfully destroy those resources. Now I'm going to ask Copilot to update the Python code so that it can read the data from S3 and dynamically generate the NPS score whenever Bedrock calls this function. Moving on to the next step, I'm going to enter another Copilot prompt to generate a Python-based backend application. I call that application as FastAPI. This application will expose a couple of API endpoints, and these APIs will act as a glue, handling requests from the users and connecting those requests back to Amazon Bedrock. Let us give Copilot around 10 to 20 seconds to create these files. There you go, it is creating. Click on continue. There you go, it created the application now. In the previous prompt, it just created the basic Java application. But if we want to run this application in production, we need to enable a couple of more features like unit test cases and logging and error handling, and making sure that the AWS clients are having the right retry settings and the backup settings, etc. And also this new prompt will enable a couple of more APIs. Now let us give a minute for Copilot to update this code with the new features. Okay, it is updating the Docker file, it's updating the README file. Couple of seconds. Oh, there you go, it's completed now. So far, we have created the Terraform code to provision the S3 bucket and the Lambda function, and a Java-based API application to act as a middleware between the front-end UI and the back-end AWS resources like Bedrock, S3, and Lambda function. Now I'm executing the Terraform commands to re-provision the S3 bucket and the Lambda function since we have destroyed previously. Let us quickly navigate through the AWS console to make sure that they have been recreated successfully. There you go, we can see the S3 bucket. Now going into the Lambda function, yeah, there you go, the Lambda function has been recreated successfully. So are we done at this stage? The answer is no, we still have a long way to go. Moving forward to the next step, I'm going to enter another Copilot prompt to provision the Amazon Bedrock Knowledge Base and also the OpenSearch serverless cluster to store the document collections. This is to make sure that we are able to provision all the AWS resources through the Terraform framework. And as you can see, when the Copilot updates the Terraform code, it also executes the Terraform commands to provision those resources. And as usual, we got hit with the IAM policy issues when it was trying to create the OpenSearch serverless collections. And I updated the IAM policies with the respective missing IAM permissions and then tried to rerun the Terraform apply commands. However, nothing was helpful to me, so I finally ended up asking help with the Copilot. And here is where it got interesting. Copilot actually stumbled. IAM policies were complex, and at first it tried to push me toward manual steps. But I stopped it and gave a stricter instruction saying that everything must be provisioned only through Terraform, no manual console work. With that constraint, Copilot revised the code, fixed the errors, and finally got everything right. And it was able to successfully create all the resources, including the Bedrock Knowledge Base and the OpenSearch, serverless clusters, etc. Everything was created only through the automation. Finally, to retest the reliability of the Terraform code, I entered a prompt asking Copilot to do the final Terraform destroy and recreate all the resources, including the S3 bucket, Lambda function, Amazon Bedrock, and OpenSearch serverless clusters, everything through the Terraform, and it is trying to recreate everything. And as you can see in the screen, it was able to successfully recreate all these resources. Now that Terraform has created all of our AWS resources, it's time to bring the FastAPI application online. To do that, I dropped in another Copilot prompt asking it to handle the Docker deployment. At first, things looked smooth. Copilot generated the Docker configuration, spinned up the commands, but then I noticed something off. Some of the config values did not line up correctly with what Terraform actually provisioned. Instead of letting it slide, I interrupted Copilot and entered a new prompt, asking it to cross-check those values against the Terraform output command. And here is the cool part. Copilot acknowledged the correction, rewrote the config with the right values, and redeployed the service again. This time, everything came up clean. The container started successfully, FastAPI launched successfully, and just like that, the API docs are live in the browser. We have gone from code to a running backend without writing a single Docker file by hand. With the API docs now live, the next step is obvious. We need a real UI to interact with these API endpoints. So I gave Copilot another prompt. Build the frontend and package it into the same Docker container as our backend application. Copilot jumped into action, scaffolding the front-end code and wiring it up. But then I noticed something strange. Instead of fully rebuilding and redeploying the containers, Copilot just kept restarting them after code changes. That's not how Docker deployments are supposed to work, and it was a red flag. So I paused the process and stepped in with a new prompt, asking Copilot to double-check the workflow. And here is the cool part. It recognized the mistakes and adjusted the approach, and this time it did everything right. It fully rebuilt the application and properly redeployed the containers. The containers came up cleanly, and when the browser refreshed, the front-end UI was there ready to go. Alright, it's time to put this new UI to the test. Let's try a simple query. Show me the top 2 products with the most negative reviews. I hit enter and error. The UI just broke on us. No worries, this is where Copilot really shines. Let me ask it to investigate and see what Copilot can do with this error and if it is able to fix it. Let us provide the prompt here and hit enter. Within few seconds, it scans the application logs and points out an issue with AWS credentials. Copilot even suggested a fix, and it also patched it, redeployed, and try again. There you go. It just says it completely resolved now. Let's again ask the same question. Let's see what comes up. Again the same error. Still no luck. Let's also navigate through a couple of other UIs as well. Other flows in the UI. Product ID, again the same error, failed to get NPS data. After troubleshooting a bit deeper, it turns out the issue is not really with the code. It looks like the issue is with the data. Without good data, even the best AI application cannot deliver meaningful results. So instead of manually crafting data sets, I decided to bring Copilot back into the picture. I asked it to add a brand new API to our FastAPI backend, one that can automatically generate synthetic product reviews, upload them straight into our S3 bucket, and then trigger a data sync into our Amazon Bedrock Knowledge Base. In other words, we are giving our AI its very first dataset to actually work with. Let us see if this unblocks the real potential of our application. And just like that, Copilot spun up a brand new API for us, a data generator that we can actually see here in the UI. To put it to the test, I fired off a quick curl command to trigger the API. Within seconds, the synthetic product reviews were generated and seamlessly uploaded into our S3 bucket. This is the turning point. Now our AI system finally has some data to chew on. With the knowledge base updated, we are ready to ask real questions and get real answers. Let us quickly enter another prompt to check if it is working. It looks like we are still having the same problem that we have been facing in the previous iteration. Let us give another refresh and try a different question. Instead of positive reviews, we are asking the negative reviews this time. It's again the same error we are getting. We don't have any choice. Let us ask a Copilot to see if it can debug further and help us with this issue. So I'm again prompting Copilot with the error message and see if it can help. Hit enter. Copilot is working on right now, so it is acknowledging the prompt, and now it is checking the logs of the container to see what's going on. And yeah, so it says I can see the issue. It says invalid or missing API key error. So from the logs, it identified some issues with the API keys, and it is trying to fix that issue. Let us see if it is able to fix that issue or not. It is doing job. It's trying to build the container again. Just give a minute. Okay, we'll try a different prompt this time. Top 3 products that received the highest negative reviews and why. Wow, this time it was successful. The AI application is able to fetch the data and provide the proper answer for the question that we have entered. This is fantastic. Now let us try other flows as well. Oh, it is able to get the NPS lookup data as well. The result is 50. Let's try for the different product ID. It is having the same NPS score for other product as well. Let's try for clothing. It's the same NPS score is returned for all the products. That looks like some problem. Let's do the compare products. It's fetching the data. Okay, it got the results and it's able to compare between the 2 products. Let's see if product report is working. Let's check for clothing. Okay, it got the product report. But we are seeing the same NPS score for all the products. So that seems to be some defect somewhere. Let us take Copilot's help to debug that issue. Okay, it acknowledged the issue and it is investigating the NPS calculation issue. So it looks like there is a hard-coded default value of 50 for the NPS score that is configured in the Lambda function. That is what Copilot has identified. However, while Copilot was debugging this issue, I was also looking into the Python code on the side and noticed that there are some configuration issues related to the S3 bucket and the respective key values in the Lambda functions configuration. So I'm entering another Copilot prompt to double check those bucket and key value details in the environment variables of the Lambda configuration. So that is the prompt I'm entering here to double check and asking the Copilot to fix that issue if there are any issues with those two values. And it acknowledged that prompt and it is trying to cross-check those environment variables configured in the Lambda function. While Copilot was busy troubleshooting, I decided to double-check the configurations myself. And here is where I spotted something strange but important. The S3 bucket path was off. Bedrock expects to read data from the data directory, but Copilot had been writing everything into synthetic underscore data, which meant Bedrock couldn't see the latest uploaded files at all. So I prompted Copilot to review the configurations again, but it stumbled a bit and did not quite fix it on the first attempt. So I gave it a much clearer prompt, specifically instructing it to update the synthetic data generator API to upload the data directly into the data directory. Otherwise, I would have been stuck manually syncing files back and forth. This time, with the clear instructions, Copilot nailed the issue. It fixed the configuration issues, and the pipeline was clean, and the knowledge base was finally able to get the right data from the right place. And finally, after all the debugging, fine-tuning, and course corrections, the Market Analyst AI application is ready for one last validation. Here is the first test prompt, and it works. The application is returning the correct insights. Let's try another one. Perfect, that one works too. Now let's check the NPS scores across different products. The first product comes back with an NPS score of 60, the second one with 50. Let's do few more tests. Okay, all these tests are successful. This is it, end-to-end production-style AI application built almost entirely with AI itself. What's amazing is that GitHub Copilot handled most of the heavy lifting, writing Terraform, Lambda, FastAPI, Docker, Bedrock integrations, and yet as developers we still had to stay sharp. Copilot is powerful, but it's not a substitute for judgment. You saw how important it was to step in, debug, and give precise guidance to keep the project on track. If you found this hands-on demo valuable, Make sure to like the video, subscribe to the channel, and share your thoughts in the comments. Would you like to see a full crash course where I break this down step by step in detail? Let me know in the comments below. Thank you for watching, and I will see you in the next video. Stay tuned.